In this section, we will investigate the law of cosines, which allows us to find all 6 measures of any triangle, provided we are given 2 sides and the included angle, or we are given the measures of all 3 sides. These are the side-angle-side and the side-side-side cases, respectively. Both cases require the use of the law of cosines. We will also learn how to calculate the area of any triangle. Hi, my name is Tom Atwater. Let's take a look at the law of cosines. In any triangle ABC with sides little a, little b, little c, we can say that little a squared is equal to little b squared plus little c squared minus 2 times little b, little c cosine of angle A. But we can also rewrite the law of cosines based on using angle B and finding its cosine. In that case, it's side B that's isolated on the left-hand side. And so similarly, if we are going to use angle C and find the cosine of that, little c is the isolated side, and of course, that would leave us sides A and B as the 2 sides for the formula on the right-hand side of the problem. Let's take a look at an example where we know the length of 2 sides and the measure of 1 angle. In this example, we would have side angle side. A surveyor wishes to find the distance between 2 points A and B on opposite sides of a lake. While standing at point C, she finds that length AC is equal to 259 meters. Length BC is equal to 423 meters, and the angle ACB measures 132 degrees 40 minutes. Find the distance AB, and here's the graphic that shows what the surveyor was looking at. It gives us the angle C as measured 132 degrees 40 minutes. It gives us side A as 423 meters, and it gives us side B as 259 meters. We wish to find side C, which means that's the variable that will be isolated on the left-hand side of the equation. So let me go to the board, and I'll quickly redraw this and then use the law of cosines to find the distance across the lake. I'll draw a mini version of this picture. So we have this type of situation where this is the distance across the lake. We know that this is 423 meters, and we know that this is 259 meters, and we know that this angle is 132 degrees 40 minutes. So to set up the law of sines, it looks like this. We take the c squared and isolate that on the left-hand side. C squared is going to be equal to a squared, 423 squared, plus b squared, 259 squared, minus 2 times a times b times the cosine of angle C. Of course, we have to work out all of that mathematics, and we would find that c squared is going to be equal to 394,510.6, and then c itself would be equal to 628 meters. So the distance across the lake is 628 meters. Now, let's take an example where we know the length of 2 sides and 1 angle, and we want to find all the other unknown measures, all 3 of them. And here we have solve triangle ABC if angle A is 42.3 degrees, side B is 12.9 meters, and side C is 15.4 meters. So you can see on the diagram what we're interested in finding would be side A. We then want to find angle B, and we want to find angle C. We can start this problem by using the law of cosines because we have two sides and the angle between them. Let me quickly redraw the triangle. What we're given then is information that this is 12.9, and this is B, that C is 15.4, and that angle A, which is this measure, is 42.3 degrees. So we need little side A, we need angle B, and angle C. So we can find A by using the law of cosines. We can say that A squared is equal to B squared, 12.9 squared, plus 15.4 squared, which is C squared, minus 2 times B times C, and then multiply that by the cosine of angle A, 42.3 degrees. All right, we have to work all of that out in the mathematics, and we'll find that A squared is equal to 109, and that A is equal to approximately 10.47 meters. And that would be our side A. Now, we have two remaining angles, B and C. Since we now know all three sides, we know that angle B must be the smaller one because it has the smaller side opposite it. Opposite C is 15.4 and opposite B is 12.9. Therefore, obviously B cannot be obtuse. We can use the law of sines to find the measure of angle B. So let's do that. We'd set it up. Sine of angle B divided by the side B, 12.9, equals the sine of angle A, 42.3, divided by side A, which we just calculated as 10.47. When we multiply this side by 12.9, we'll find sine of angle B is equal to 0.829213255. Using inverse sine on the calculator will give us an answer for B of 56.0 degrees. To calculate angle C, yeah, we could go through and use the law of sines again, but it's a whole lot easier to realize that now that we have angles A and B, we can simply add together 56 plus 42.3, which gives us 98.3, subtract that from 180, and get that angle C is 81.7 degrees. Well, now I would like you to try a problem in which you are given the lengths of all three sides. Solve the triangle for angles A, B, and C. Round to the nearest tenth. And you can see the triangle. You have the sides 5 opposite A, 7 opposite B, and 9 opposite C. Pause the video to work on this problem, and when you are finished, restart the video to check your answer. Welcome back. Let's see how you did on this. Of course, let me sketch this triangle very quickly. I have sides of 5, 7, and 9. My triangle A, B, C. So let's start by finding angle C first. So to find angle C, we would set up 9 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of angle C, which then means I need to subtract these squares from here and then divide by the coefficient of cosine C. So what that would look like would be cosine C is equal to 81 minus 25 minus 49, all divided by negative 70. When I plug that into the calculator and work it out, I'll find that cosine of C is equal to negative 1/10. And when I plug that in inverse cosine, I'll find that angle C is equal to 95.7 degrees. Well, now that I have this angle, 95.7 degrees, I could use the law of sines, which you'll notice that it has fewer calculations in it than the law of cosines. So that's a lot of mathematicians would choose the law of sines over the law of cosines for that reason. So if we wanted to find angle A, we would set it up and say the sine of angle A divided by, of course, side A, which is 5, is equal to the sine of angle C. And the sine of angle C is the sine of 95.7 that we just calculated, and that would be divided by 9. When I work all of that out, I would find that the sine of angle A is going to be equal to 0.55280,865. And when I do inverse sine on the calculator, I would find that angle A is 33.6 degrees. So let me write that in my triangle, 33.6 degrees. And so now to find angle B, all I need to do is add together 33.6 plus 95.7, subtract that from 180, and I'll find that angle B is 50.7 degrees. So I now have my complete triangle solved, all 3 angles, and I was given the 3 sides. Now, the law of cosines can be used to derive a formula for the area of a triangle, provided that we are given the lengths of all 3 sides. The formula is known as Heron's formula. Let's take a look. If a triangle has sides of lengths A, B, and C, and if the semi-perimeter is equal to little s equals 1/2 the sum of the quantity A plus B plus C, then the area of the triangle is equal to big A for area equals the square root of the entire quantity, the product of S times S minus A times S minus B times S minus C. The best way to get familiar with this formula is to look at an example. So we have the distance as the crow flies from Los Angeles to New York is 2,451 miles. From New York to Montreal is 331 miles, and from Montreal to Los Angeles is 2,427 miles. what is the area of the triangular region having these three cities as vertices? Ignore the curvature of the Earth. Of course, we want to ignore the curvature of the Earth because that would change that slightly. And when we talk about the crow flies, we'll assume it's a completely straight line. Well, the first thing we need to do is calculate the semi-perimeter. And remember, the semi-perimeter, little s, is equal to half of the sum of the lengths of the sides. So therefore, I need that little s is going to be 1/2 of each of those distances. So we have from Los Angeles to New York is 2,451 miles. From New York to Montreal is 331 miles. And then from Montreal to LA is 2,427 miles. Add all of that up, take half of it, and you'll find that S is equal to 2,604.5. Now, we can use the Huron's formula for area, which tells us that the area is equal to the square root of S, which is 2,604.5, times S minus A, 2,604.5 minus A, which is 2,451. Then times, and I'm going to bring it down here for the space, 2,000, and it's going to be S minus B. So that's 2,604.5 minus 331 times S minus C, 2,604.5 minus 2,427. So realize that all of this is underneath the square root. We're multiplying all of that together. We would find that the area is going to be 1,700 square miles. All right. Well, there's another formula that we can use to find the area of a triangle when we are given the length of two sides and the angle between them. So that's side angle side. In any triangle ABC, the area is given by the following formulas. Area is equal to 1/2 BC sine A. So what we're saying there is that we have the angle A, which is between sides B and C. Any version of this works, and that is to say we could also calculate the area if we know sides A and B and the angle between them, which of course is the angle C. But we also have one other possibility, that the area is equal to 1/2 AC sine B. So that is to say the area is half the product of the lengths of the two sides and the sine of the angle included between them. Let's take a look at an example that will demonstrate the use of these formulas. Find the area of the triangle ABC given angle B is 55 degrees, side A is 34 feet, and that side C is 42 feet. So we have the necessary information, which is two sides and the angle between them. So we can find the area by using that formula. Area equals 1/2 the product of the two sides, 34 times 42 times the sine of the angle between them, which would be 55 degrees. So you work all of that out, obviously using your calculator for the sine of 55, multiplying by the 34 and the 42, and then dividing that all by 2, you'll find that the area of this triangle is equal to 585 square feet. Well, we have seen how to find the area of a triangle given the length of the three sides, or given the length of two sides and the included angle. But what about when we are given the measures of an angle, a side, and another angle. To solve this type of problem, we use the law of sines and the area formulas in combination. So here's an example. Find the area of a triangle ABC if angle A is 24 degrees 40 minutes, side B is 27.3 centimeters, and angle C is equal to 52 degrees 40 minutes. Let's draw a sketch to make sure we see where we're going with this problem. So we have triangle ABC, where we're given that angle A is 24 degrees 40 minutes. We're given that side B is equal to 27.3, and we're given that angle C is 52 degrees 40 minutes. So the first thing we probably want to do here would be to find angle B. How do I know that? Well, I have side B, which is always an indication that it would be good to know that what angle B is, because then you can use law of sines to find another side. So angle B, we just have to add up 24 degrees 40 minutes plus 52 degrees 40 minutes, subtract it from 180, and we'd find that angle B is 102 degrees and 40 minutes. Now we can find side A. And we do that using the law of sines. So side A is equal to, side A over the sine of angle A, 24 degrees 40 minutes, is equal to side B, which is 27.3 over the sine of angle B, 102 degrees 40 minutes. Multiply the sine of 24 degrees 40 minutes up here. We'll find that little a is equal to approximately 11.7 centimeters. So now we can find the area because we have side, the angle between them. So we would set it up as the area equals 1/2 side A, 11.7, times side B, 27.3, times the sine of angle C, 52 degrees, 40 minutes. Plug all that into your calculator and you'll find that the area is equal to 127 square centimeters. Great job in today's lesson. A lot of good work on those formulas. Now in this lesson, we learned about the law of cosines, which allows us to find all 6 measures of any triangle, provided we're given 2 sides and the included angle, or all 3 sides. We also learned how to calculate the area of any triangle. Be sure to work the exercises that your teacher assigns, and we'll see you next time.